Hi, in this video we're going to look at how to solve a quadratic equation by completing the square. Now there are other ways to solve quadratic equations, such as using the quadratic formula and factorization, but completing the square is particularly useful because not only can it enable us to find the solutions to quadratic equations, but it can also help us to identify the turning points of the quadratic curve without having to draw the graph. It's worth noting that the quadratic formula itself is derived by completing the square, and I'll be covering this in another video, so please see the link in the description if you wanted to have a look at this. So let's have a look at an example. This question asks us to solve the equation x squared plus 8x plus 13 is equal to 0 by completing the square and to give your answer in surd form. Okay, the first step is to change the x squared term to an x and then add half of the coefficient of the x term. Coefficient just means the number in front of a variable, in this case x, so half of 8 is 4. So we now have x plus 4. Next, square the x plus 4 to give x plus 4 squared. We then subtract the square of the second term in the bracket. 4 squared is 16, so we subtract 16. It's probably a good idea to pause here to have a look at what we have just done, as it's sometimes not obvious what you're doing when first learning this procedure. To see what we've done, let's expand the x plus 4 squared and then subtract the 16 and compare it to the expression in the original equation. So x plus 4 squared is x plus 4 times x plus 4. Expanding this gives x squared plus 4x plus 16. Collecting like terms gives x squared plus 8x plus 16. Then let's subtract the 16, which gives x squared plus 8x. Notice how this is exactly the same as the first two terms in the original expression. So all we have to do is add the 13 and then both expressions will be equal to each other. The difference is we now have a linear expression squared instead of a quadratic expression, which is going to be easier to solve. A linear expression is where the highest power of x is 1, whereas a quadratic expression is where the highest power is 2. So we are now in a position to solve this equation. We have x plus 4 squared minus 16 plus 13 is equal to 0, which then gives x plus 4 squared minus 3 is equal to 0. So x plus 4 squared is equal to 3, and therefore x plus 4 is equal to plus or minus the square root of 3. So x is minus 4 plus or minus the square root of 3. We now have a solution to this question. X is equal to minus 4 plus the square root of 3, and x equals minus 4 minus the square root of 3. And because we have exact answers in terms of square roots, we have correctly given our answers in surd form. Now, although the question doesn't ask for this, let's also look at how completing the square can identify the turning point of a quadratic curve. So you've just seen how the quadratic expression x squared plus 8x plus 13 can be transformed by completing the square to x plus 4 squared minus 3. The turning point of this curve is minus 4 minus 3. In other words, the coordinates of the turning point, or the minimum of this quadratic curve, is minus 4 minus 3. The x-coordinate is found by finding the value of x, which would make the expression in the bracket equal to 0. This is minus 4. The y-coordinate is the value outside the bracket, in this case minus 3. To see this graphically, let's look at the equation y is equal to x squared. If we add 4 to the x inside the bracket, this moves the graph 4 units to the left in the x direction, which is actually counterintuitive to what you might have thought. If we then subtract 3 outside of the bracket, the graph moves 3 units down in the y direction. And as you can see, the turning point is minus 4 minus 3. Okay, so that's how you solve a quadratic equation using completing the square method. Hopefully you found it useful, and if you did, please like and subscribe to my channel, and thanks for watching.